So, a major breakthrough has just happened in a field that feels like it's straight out of science fiction. Technology that can decode our thoughts directly from our brain signals and turn them into text. This is a huge leap forward that could completely change how we communicate. Okay, let's dive right in.
I mean, really think about that for a second. What if a computer could grasp the meaning of what you're thinking, the actual idea, and put it into words, all without you saying a thing or typing a single key? It sounds like something from a movie, but it is happening right now.
And look at this. This is incredible. These are not just wild guesses. On the left, you've got the ground truth, which is what someone was actually thinking about typing. And on the right, that's what the AI model predicted just from looking at their brain signals in the moments before they did anything. Somebody thinks the room seemed colder, and the model decodes there was a breeze, even a gentle gust. It's not getting the exact words. It's getting the essence, the core meaning.
So how in the world did we get here? Well, this huge leap forward wasn't just about cooking up a slightly smarter algorithm. No, this was about cracking a really fundamental problem that's been holding the entire field of brain-computer interfaces back for a very long time.
And that's it, right there. The single biggest hurdle was data, plain and simple. If you want to train an AI to understand the ridiculously complex signals firing inside the human brain, you need a mountain of examples. And for years, researchers just didn't have anywhere near enough.
Let's really talk about the scale of this challenge for a minute, because it puts this whole achievement into a totally new light. The gap between what the field had and what it needed, it was just massive.
Up until this point, the biggest datasets that paired brain activity with language, we call them neuro-language datasets, they all added up to less than 200 hours. Now, that might sound like a decent amount, but for training a modern AI, it's barely a drop in the ocean. And it wasn't just that the hours were low. These datasets were also collected from a really small, limited group of people. So, trying to build a model that could work on someone new, someone whose brain it had never seen before, it was almost impossible.
And then, this. From less than 200 hours to 10,000. This isn't just a small step up. This is a complete game changer. It's a whole new world in terms of the data we now have to work with.
And here's the kicker: how they did it. They gathered all this data, a truly unprecedented amount, in just 6 months. And they got it from thousands of different people. That variety, that diversity of minds is every bit as important as the huge number of hours.
You know, the story behind how they collected all this data is just as wild as the tech itself. This wasn't done in some huge, sterile, shiny lab. Nope. This was a scrappy, super intense, all-hands-on-deck operation run out of a basement. For months on end, thousands of volunteers were filing into this place, 20 hours a day, 7 days a week. They'd go into a little booth, get fitted with a custom, non-invasive headset, and then for 2 hours, they'd just have a conversation with a really advanced AI.
Now at first, getting good data was tough. You can see on the left, some of the early typing was just gibberish. But the team figured out how to make the AI conversations more personal and interesting, which encouraged people to really engage. And by October, you see people having these deep, thoughtful chats, giving the model incredibly rich data to learn from.
The whole operation got so big, it became sort of a local legend in San Francisco. It actually got to the point where team members would hop in an Uber and the driver would start telling them about this great new side hustle for making money, and it turned out to be their own project. That's when you know you've hit a crazy scale.
So, in the middle of collecting all this data, the team stumbled upon a really counterintuitive discovery, something that kind of flips the old way of thinking completely on its head.
Okay, so here's a classic problem in this field. You can use gel with the electrodes on the headset, which gives you really clean, high-quality data, but the setup takes a whole 30 minutes. Or you can use dry electrodes. They're way faster, like a 3-minute setup, but the data you get is a bit noisier. The team made a bold choice. They bet on speed and quantity over perfection.
In the beginning, they were totally obsessed with getting perfect, clean data. I mean, they went to extreme lengths. They were layering rubber mats, running equipment off these giant, heavy-duty batteries, and even cutting the power to half the building just to kill any electrical interference. But here's the breakthrough moment. After they had collected around 4,000 or 5,000 hours of data, they had this huge realization. The sheer amount of data was more powerful than any fancy noise reduction trick they could ever come up with. The quantity just swamped the quality issue.
So why does that work? Well, when you have enough examples from enough different people in enough slightly different environments, the AI model just gets smart enough to figure it out. It learns to separate the actual brain signal that's related to a thought from all the random background noise. It can tell the difference between this signal changes when the thought changes and, oh, that's just the hum of the air conditioner. It learns to find the signal in all the mess.
So what's the big picture here? What does all this mean for us? Well, this breakthrough isn't just some cool lab experiment. It pushes us way, way closer to a future where brain-computer interfaces could actually be a part of our daily lives.
So if you're going to remember anything, it's this. First, massive, diverse datasets are the absolute key to making this thought-to-text technology work. Second, being able to actually operate at that massive scale is a true superpower in the world of AI today. And finally, all of this means we are one giant leap closer to a brand new way of communicating.
And that leaves us with one last really big question to think about. This isn't just about decoding words. It's about decoding the meaning behind our unspoken thoughts. So when a technology this powerful finally arrives, what kind of rules are we going to need? What conversations do we need to start having right now?